going to finish talking about severe elements of weather. That would include lightning. We talked about hail before. Things that make a thunderstorm severe. Hail, lightning, wind, and then tornadoes. And so the National Weather Service, if they issue, remember, a warning is worse than a watch. A watch is like, oh, just be careful. A warning is like, okay, there's something going on. And it's been noted either to spawn tornadoes, give a certain size hail, certain intensity of wind, or have severe lightning. So most of the lightning won't get you. Remember we said it's the cloud to cloud, otherwise known as sheet lightning. The 20% that will get you, actually cloud to ground, it kind of, if you're a target, you're going to feel your head start to kind of tingle. It's true. So there's a question on your test tomorrow about the audible part of lightning, which is called thunder. And sometimes I need to concentrate on these terms. So thunder is what you hear, lightning is what you see. Okay, you see lightning and you hear thunder. So what creates thunder is actually this bolt of lightning. Kind of showed this would be like what, cloud to ground lightning, or if it's cloud to cloud, it doesn't matter. The reason you see it is that you are actually seeing, the handiwork of electrons flowing from point A to point B. So basically there's a buildup of electrons somewhere and the electron deficient somewhere else, and the electrons say, I'm out of here. Okay. So when those electrons move, they actually heat up the region where, if this is the bolt, kind of a round bolt, very hot air. Hot air is fine, but it heats it up. Hot air is fine, and with hot air, we know that hot air will rise, hot air will also expand. So literally, the air molecules move really fast. They move faster than the speed of sound. Is that not crazy or what? So air relocating from where the bolt is outward faster than the speed of sound. And so it creates a sonic boom. So our thunder is a sonic boom. No wonder the dogs are so scared. You know, right? And if you've maybe heard of this before, that you can count the delay. So what do I mean by delay? Well, you're gonna the photons of light are gonna travel faster from the lightning bolt than the sound is. Okay, so there's the delay. And the farther away the lightning bolt is from you, the bigger that delay. So in general, and I heard 5, and I've seen different things on the internet, but if you count 5, so you'll see the lightning come 1001, 1002, 1003, 1004, 1005. If you count 5 seconds, then it's a mile away. If you count 10 seconds, it's 2 miles away. If you count 3 seconds, it's less than a mile. If you count 1 second, it's almost on top of you. Okay, so that's how that works. Lightning in miles. So the number of seconds divided by 5 will give you how far away that lightning bolt is. And remember, you heard it here first now, you probably. But if you can actually hear thunder, then that event, those strokes of lightning are close enough to reach you. I know it seems, are you serious? Because actually there's something called heat lightning. And what heat lightning is, and the reason it got the word heat is just because it kind of happens on kind of warm, muggy nights, it seems like. It's most notable. Well, it can happen during the daytime too, heat lightning. So the thing with heat lightning is you see it, but you don't hear it. And the reason you don't hear it is because that sound went in all directions, like normal thunder does, but it basically diluted by the time it got to you. So it was too diluted. So about 12 miles is the criteria for that. My last thing is kind of the 2 types of thunders. And they go with a little bit the proximity of the lightning bolt. Like if you hear a, you're like, oh crap. Okay, so it's probably pretty close. The other one is, especially kind of if you're outdoors and you hear the, kind of like the bass sort of rolling sort of thunder. And the reason it's rolling is because actually the sound is kind of percussing or hitting off the hills and kind of coming towards you. So there are lightning, Mother Nature's wonderful light show. So I have a video to show you about tornadoes, the 5 top tornado footage. So tornadoes, like lightning, like hail, like severe precipitation, will occur when the thunderstorm cell is in its mature stage. So tornadoes. what are you looking for? Well, you're going to look for kind of the bottom of the cloud, and you're going to see this one's a classic. So let me grab my pencil here. You can see the base of the cumulonimbus cloud in its mature stage, and it's called a wall cloud. So actually, this is a pretty good example. Can you kind of see this right here? This is the wall cloud that's dropping down from the base. And you can kind of see the probably this stuff that's being thrown up, good chance it's actually kind of dust or something that's on the ground. So that thing is rotating, tornadoes rotate, and they also suck, they really do. They take, they are let's see, what would that be? Yeah, they're low pressure down here at the Earth's surface, and so low to high, so actually not only they're spinning, but they are sucking. Rising air. Just like we have an eye of a hurricane, we also have an eye of a tornado. Of course, tornadoes, like you know, are more short-lived, and they're smaller than hurricanes, obviously. But that low can be pretty darn intense. So the shapes of tornadoes vary a lot, and I don't know all the shapes, obviously, but I've heard this one might be called a rope shape. Does it look like a rope? And this one might be called a wedge shape, W-E-D-G-E, wedge shape. So they actually take on kind of different names of what they look like, but they have similarities. So they can vary in size up to a couple of feet to a half a mile. They vary in duration from minutes to hours, several hours. That kind of reminds me of thunderstorm cells. Yeah, you have your normal thunderstorm cell, then you have your supercell. Supercell is just a thunderstorm cell on steroids. So it can last several hours too. We're going to see kind of some statistics for some important tornadoes coming up. Wind speeds, unlike hurricanes, like I think I said, tornadoes, since they're so fast-lived, you kind of don't know where or when they're going to be, and so the best bet to categorize them is after the fact. So you kind of see all the damage they did and categorize them. So let's take a look at this video. I tried to pick out one that I thought, oh, that. Some pictures of some tornado damage down here. If you've heard tornadoes do some crazy things with the winds and the pressures, they do. Like they can make something as soft as a piece of hay, like go through a telephone pole. How does that happen? I don't know. Sometimes tornadoes happen in outbreaks. And it kind of makes sense because we talked about squall lines, where you have a bunch of thunderstorm cells that are generated at the same time, in that case from a front, weather front. So you can have, from those thunderstorm cells, multiple tornadoes. So actually in, this is showing you an aftermath, I don't know what year it was, but 84 tornadoes in that day, killed 59 people. So in the United States, the single deadliest tornado took 695 lives, close to home, Missouri, Illinois, Indiana. The year was 1925. Again, kind of like the casualties associated with the Galveston, Texas hurricane. The casualties were up when our communications were a lot less. In 1974, there was an outbreak of tornadoes, 174 tornadoes on one day. Good heavens. Mid-United States. So the widest tornado was 2.5 miles. We're going to talk about categorizing tornadoes. We did or will. And it's the EF stands for Enhanced Fujita Scale. So of course 5 is the most intense tornado, and that's 4. The highest speed was 302. And the last one I thought was kind of interesting was a personal check was carried 223 miles with the tornado, result of tornadic activity. So that's kind of neat in a weird sort of way. So, do scientists know everything there is to know about the formation of tornadoes? No, but they think it might go something like this. They think that there might be, you can recognize the cumulus stage of a thunderstorm in this middle one right here. This would be the mature stage of a thunderstorm. It's got a lot more of the thunderstorm clouds, the cumulonimbus cloud has a lot more what we call vertical development. You can see it flattening out to create the anvil. Here's those overshooting tops we talked about. And then what actually happens to make this what we call a mesocyclone in the middle, okay, is kind of rolling air down here that gets lifted up along with the cumulonimbus cloud. So things that make a thunderstorm severe include strong updrafts and strong upper level wind. And we kind of talked about that when we talked about tilted thunderstorms. Your tilted thunderstorms are more likely to be severe than your what we call majestic. The opposite of tilted is majestic. But TS, remember, stands for thunderstorms. Given 100 thunderstorms or thunderstorm cells, that remember, thunderstorm cells can bring your hail, they can bring your lightning, they can bring strong winds. But if given 100 of them, only one of them in general will give you a tornado. In general, I have the word hail here. And I'm going to kind of show you at the end of this part a little bit about what meteorologists look at. And hail oftentimes is the right before a tornado, but not always. And so over here we can kind of see the base of the cumulonimbus cloud. Kind of see it tilt a little bit, maybe. I don't know, maybe it's just one big wedge. That's just kind of a. But you see the dust being spewed up here. This is your little tornado. This is probably maybe the wall cloud right here. So on your test tomorrow, there's going to be a figure. I'm not sure it will look like this, but this shows some of the things we've been talking about with regard to cumulonimbus or thunderstorm cells. The top word is anvil. This is the anvil part. It kind of shows you the direction of motion of the thunderstorm. This thing up here, this kind of cap on the top of your cumulonimbus cloud, I call it an overshooting top. There it says penetrating top. It's the same thing. Overshooting top. And the thing it's overshooting is actually leaving the troposphere in the stratosphere. This right here, I don't know if I've said yet or not. We talked about, yeah, I think it maybe did. Maybe it's in my review video. We talked about 10 types of clouds, and there's another type of cloud called the mammatus. So it's a mammatus cloud type. And they are pouchy looking sort of things. And you'll oftentimes see them kind of on the underside of the anvil. They're pretty. And then down here, I've got the wall cloud. So kind of, this is the lifting condensation level. You can see a nice flat bottom until you get to precipitation. But extending from the bottom is kind of this shaft, cylindrical cloud called the wall cloud. And if it has, they'll tell you in spotter training, if it has some kind of spin to it, rotation to it, good chance that that's the precursor of a tornado dropping out of it. And then I have the word tornado. Tornado next to the wall cloud. Okay, so categorizing tornadoes. So the damage after the fact is when they're categorized. And how do we know if they were an EF0 to an EF5? EF0 to an EF5, that's the scale. Well, we look at the damage that was done afterwards. It was interesting, that video we watched, one of them, the guy who was talking to probably a meteorologist was trying to classify it. And I thought that was interesting. So enhanced Fujita, F-U-J-I-T-A. F-U-J-I-T-A, enhanced Fujita. It must imply that there used to be an old Fujita scale, and there was one, but now it's the enhanced Fujita. 0 is the weakest, 5 is the strongest. And this kind of, to me, is akin a little bit to hurricanes in that most tornadoes are of the weaker type, but I think even the weaker type, it could be a bad thing. 69% are EF or F0 to F1, and that only accounts for less than 5%. Less than 5%. So if we go up from 1 to actually 2 to 3, F2 to 3, a third of hurricanes, a third of tornadoes are that strong, and they account for about 30% of fatalities. So we've gone from less than 5% to 30% of all the fatalities. Well, if we have we're like at 35% there. So the rest of the fatalities must be for the strongest of the tornadoes. So only 2% are very strong tornadoes, F4 to F5 or EF4 to EF5, and yet they account for by far the most fatalities, about 70%. I have a slide coming up here to kind of give us some hints on safety with regard to tornado. So yeah, there used to be just the plain old Fujita, and now we're at the enhanced Fujita scale. That's what we use. So the word is Tornado Alley. So growing up here in the Midwest, you've probably heard about Tornado Alley. And this is color-coded, so let's see. This says, the title is The Average Number of Tornadoes Per Year per 10,000 square feet. So we kind of have a hot spot here. And it's kind of hard to see Iowa in this, but I'm like in Iowa for right there. So I guess if we go with kind of the yellow, the tan, and the brown, you could include part of Iowa there. I remember growing up, it was like Iowa State University, which I'm thinking it's purple there. They used to say it was in Tornado Alley, but you can kind of see it's not. States it goes through. This kind of rehashes what statistics you saw on the previous slide. You have your weak tornadoes, the strong tornadoes, and the violent tornadoes. The first bar says how many there are, and the second bar says how many people die. So a lot of weak, not many people die. Not as many strong, a fair number of people die. Violent, not many at all, but we have most of our deaths with the violent. It's almost like, as I'm going through it now, it's almost like if you have an EF5 coming your way, I don't know, you can hide or you can try to be safe, but it's tough. I think this figure is interesting. So it's a map of the world, and those little dots represent kind of where tornado activity is. Is it tornadoes? Yeah, tornadoes. Red dot. So what I think is interesting is how come the North America gets hammered? And I've heard it described this way, in that we have a couple of mountain ranges which is kind of unique. Well, first off, we're in the middle latitudes. You know, we have the Hadley cell, the Ferrel cell, which is in the middle latitudes, and the polar cell. So we're kind of set up for kind of clashing cold air and warm air anyway. So that's bad, but where I've drawn those, we have two mountain ranges that just kind of escort our air masses to clash and create conditions that can give us tornadoes. So in Australia, there's another reason not to go to Australia, but I want to go. We'll see. So here's some warning information. First off, some safety information. First off, I said that there's a definite difference between a warning and a watch. A warning is a big, hairy deal, and I think you probably already know this. If your family's like my family, you might have someone in it that says, "To the basement, quick now, I don't care." So, yeah. And all my family's like, "Oh, Mom, but anyway. So warnings means that it's been spotted. So get indoors if possible. If you can't get indoors, go to the basement. If you don't have a basement, at least go to a room that's in the middle of your house on the lowest level that you can. My mom and I have talked about this before. For her, I think she's got some sort of maybe mattress handy. She's going to go in. She lives in a mobile home. She's going to go in the bathroom and cover herself up. Okay, that sounds good. Cover yourself up with a mattress or some sort of padding, maybe for obvious reasons, for debris. Protect yourself. And if you're like me, we've got pets. You're like, oh, what about my pet? So just do your best. If you're in a mobile home, get out of it. So yeah, maybe I better have that discussion with Mom again. I don't know. And if you get out of it, go to a fixed building or in a ditch. Okay. If you're driving the vehicle, get off of the road and seek shelter. If you're seeking shelter outside, get to the lowest ground possible. Seems like I've seen success stories about people in culverts, they're outside. I don't know. We had a tornado drill here the other day, and I think went pretty good. Yep. And it seems like bathrooms a lot of times have the stability, whatever it is, to protect you. All right. So the last thing I want to talk about is a little bit kind of maybe the geeky side of looking at severe weather. So when we look at a surface map of kind of what the weather's doing on the United States, they will show, oftentimes they'll show kind of where it's raining, where it's precipitating, and that's just regular radar. Basically, they send out a signal, and if it doesn't come back, it means it's not raining. If it comes back, and how much it comes back is an indication it's raining and how much it's raining. Doppler radar is a little different. Doppler radar actually can get a sense for precipitation and how fast it's moving and the direction it's moving. And the benefit of that, I'll just kind of show you, I'll show you kind of looking down at it. So if you have somebody here with a Doppler radar, and they are looking at, see around the low, so it's going to go counterclockwise. They're looking at the eye of a tornado, okay, and it's raining. Actually, they are going to see a blue shift here. Goodness, I can't spell. Blue shift here and a red shift here. Just kind of like we talked about before. And it's going away, it's going to give a red shift. Coming towards you, going to give a blue shift. Now, it doesn't show up red and blue. It actually shows up red and green on their Doppler radar. Okay, so the part moving towards us, blue shift, okay, light wavelengths will be shortened, okay, and moving away, wavelengths will become longer. And remember, if we do the whole Roy G. Biv thing, sometimes I go backwards, so Roy G. Biv, okay, this is the longest wavelength, and this is the shortest. Okay, so that's all kind of how Doppler radar works. So again, it's not red and blue, but it's red and green. So you see the red and you see the green. Kind of down here is how intense the precipitation is that's creating that, what we call reflectivity, to come back to the radar. But it's actually showing you kind of an alternating red and green. So you see the word tornado here, so I'm not sure which it is. Maybe if I stood over here, Doppler radar over here, or was Doppler radar over here? I'm not sure. But red is maybe, let's see, greens represent toward and red represents away. So in Doppler radar, if you see this kind of coupling right there, that's actually what we call a tornado vortex signature, TVS. This actually term made it to your exam tomorrow. It's called a hook echo. And in order to kind of see a hook echo, you have to step back, and you're probably not looking at Doppler radar, but you step back and look for a hook. And I think on the test tomorrow, I kind of liken it to the finger, like a finger hook. And right there in the finger hook, and this is like fanned out precipitation, but a hook right there, that's where you maybe have rotation, a shaft of hail, and maybe a tornado. So the hook echo is right there. This is regular radar, this is Doppler radar. So if you find a hook echo in your radar image of precipitation, one way to look at it is basically, here it's dry, no reflectivity, and here it turns angry red, okay? And you kind of see this characteristic hook. And a lot of times on the Weather Channel or whatever, when we have some severe weather happening here, the meteorologist will talk about hook echo or the Doppler tornado vortex signature. Oops, sorry. Yeah, the word there is warning. Warning by the National Weather Service. Yeah, tornado vortex signature. And sometimes I'll hear them say that too. And that tornado vortex signature, and I'll draw a line actually, is the top image. Tornado vortex signature shows you that you have rotation because you have kind of a circular region of red and green moving toward and away. The word is signatures. TVS. So this is a hook echo right here. This is hard to kind of see. Can you see the finger? I don't know. I'm liking it right here. You can kind of see the precipitation fanning out. This is a tornado vortex signature, TVS. And then this one is specific event. Back in 1999, EF5 went over, I'm trying to think, I think the National Weather Service has a main office in, anyway, it got hit by the tornado, which almost sounds like the tornado was like, I'm going to get you. Okay, that's it. Okay, so tomorrow the test should be in this room, as far as I know. And I'll be here probably by 9 in case you have any last minute questions.